Okay, we're recording now. But I want to mention that we have an exam tomorrow, and I'm going to shoot for a 3-hour window like we did last time. I think that turned out pretty well. And make sure you allot yourself time. You don't have to stay on it for 3 set hours, but once you're going to have a 3-hour window. I'll start the main class time at 10:20 until 1:20. If you have a better 3-hour window that'll work for you, I've already had one person put in a request for it. Let me know, and I'll make adjustments according to that and set you up in the system so that the 3-hour window will be different for you. Otherwise, it'll be from 10:20 until 1:20 in the afternoon tomorrow. All right? And good. I hope you all were able to look at your quizzes. I want to kind of show you how the grades ended up falling. Just to let you know, you did reasonably well on the quiz. I'm going to turn it over to iPad just for a second. And I've got another problem we're going to be doing in just a second there in the iPad, so just bear with that. But the scores ended up being 18 and above. There were a total of, there were 6 of you that got 20 or above. There were 10 of you that scored between 18 and 20. And that means there were 16 total that were in the 90% or better range, 90% or better range. Yeah. And then 80%, there were 3, 4 here, 0 here, and there was 1 that was less than 12. All right. And it is a matter of making sure you're solid on it. It looks like in general, you guys are in a good way. There are some basic fundamentals I want to stress though. And some of you got some nitpicking. Oh, also, those of you, the way the system's set up, the way I set up the grade book at the beginning, the max you could score on a quiz is 20. So all of you that scored more than 20, and there were 6 of you that scored 20 or better, you only got 20. And I've got it recorded in the book. I will give you the credit of that decimal or more added to your score. It'll be on top of that, and it'll be put somewhere else. I'll make adjustments in some way. It's not a huge amount, but it is a little bit more than 20 a few of you did. So I will make sure you get that downstream. Okay, any questions at all about the scoring or anything like that right now? Okay, so do you have questions now about quiz 2? Were there any specifics? I'm going to open it just for a moment, and then I want to get on to a couple other things, and then we can come back to answering questions you have at the end, okay? But if anybody have anything immediately about, oh, yeah, let me say one thing that did come up a lot, okay? One thing I'd asked you guys to do, and I don't know if you remember it vividly or if I put it on the quiz explicitly or not, I don't have that in front of me, but the idea of make sure you designate what the derivative is. As soon as you start taking the derivative, I want you to use how was the original function given, okay? Several of you said d dx equals, okay, d dx of what? So if the problem was giving you y equals the original function, then y prime is the derivative. If it was f of x, then f prime of x, okay? And if it was m of x, then it's m prime. N, P, Q, all the way through. I use different letters, and G. And I asked you, though, to make sure you use that. So make sure tomorrow on the test that you remember, if I denote a formula, if I give you an equation of some sort, and notice it is equation. The question asked for an equation, and a couple of you didn't include y equals when you wrote it. Equation means both sides of the equal sign, all right? So I'm nitpicking enough on this that I want you to be able to, when teaching Calc 2, I found that people did not clearly designate when they started taking a derivative. You need to be able to know that, and you need to be able to show that. I want you to show me that you know it, okay? So when you start taking the derivative, using the label that they gave, unless you redefine it somewhere. If you want to say y equals m of x, then you want to use y, that's fine. But the final answer needs to be in terms of the original formula, okay? So several of you lost 0.2 of a point And some of you used it somewhere in the process. Maybe you put it on your answer, but you didn't show it when you started taking the derivative. I want you to do that. Get in the habit of doing that. And that's going to carry you into Calc 2. It's going to carry you into Calc 3. You need to be able to distinguish when you start taking a derivative of something, okay? Are there any questions on that at all? Okay, anybody thought of a question on quiz 2?
Yeah, I got a question.
Go.
I think it's
Thomas, is that right? Go for it.
all right, here I am. It's number 4B.
B as in boy, as in boy.
Yeah, 4 Bravo.
Yeah.
I got a negative answer, but I really can't read your writing. I'm not sure. Is the answer to that supposed to be negative?
Oh, I see. Well, part of the issue is this. There were a couple of you, the answer turned out on top. If you just read it straightforward as it is, the denominator is the denominator squared. So it's x squared plus 2, parentheses around it, squared would be a really good answer. Some of you multiplied that out. And what you got to be careful on, you guys, if you multiply it out, I think that might have happened to, I don't know if it was you, Thomas, but you got the middle term needed to be x squared. The first term had to be x to the 4th, then the middle term had to be x squared term, you know, and then a constant. But on top, it ended up being on top minus x squared minus 2x plus 2. And Thomas, I believe on yours, I think that minus sign, it looks like it came off of your x squared.
So yeah, I factored out a -1, so I just made the whole number negative, but the top was x squared plus 2x minus 2.
Okay, so that means then it should be, okay, so if you took the minus sign out front and there's a negative out front, even with the bar, if it's above, then make sure you put parentheses around the number, around the trinomial. But it should be plus, you know, not, you don't need a plus sign, but it should be x squared plus 2x minus 2. Is that what you have?
Yeah, that's what I got, but I got the negative symbol in front. I mean, it's just like a technicality. I mean, I don't know.
Okay, so it makes a big difference though. So if you brought the negative down front, then plus x squared plus 2x minus 2 is what should be up there. But that
Okay, I got you.
sign, I couldn't tell if you had the minus sign on the x squared originally. That wasn't 100% sure. So that's what I think I was asking you a question there about what did you do there? And I think I gave you credit for it for that.
Okay, yeah, okay, I got you.
Okay, good. Any other questions at all on quiz 2? Oh, you guys also on part E. Look at that. If you left it, because I did not explicitly say no negative exponents, or if you start with a radical, end with a radical. I'm going to say that on the exam, so remember that, okay? But I gave you extra points if you came up with, on the term that is the square root of x, when you took the derivative of that, you end up with 1/2 x to the -1/2, okay? If you put that, you got full credit. If you put the x to the 1/2 down in the denominator, then I gave you plus 0.1. If you change that x to the 1/2 to the square root of x down there, I gave you plus 0.2, okay? Because I didn't specify it, that was over and above the call. That was cool. But on the tomorrow, on the test, I'm gonna say it in the instructions. No negative exponents when you're done, and if it starts with a radical, end with a radical. So it would be something taken off if you left it as x to the -1/2, okay? Or if you took it positive 1/2 in the denominator. Now there were a couple of you got to be mindful that when you use a slant division bar, okay, on your calculator, on your TI calculator and on Desmos, I believe, if you have 1/2, then that is 1/2. If x is right after it, that x is not in the denominator, okay? If you have 1/2x, The 1 and the 2 go together with that division bar, but the x is a product. So the x is not in the denominator, even though it looks like it's right beside the 2. So you got to be careful that when you use if you use a slash, like on your calculator, you need to have parentheses around that 1/2. Or if the x is in the denominator, put the 2 with the x and close that together, So part of the situation is the slash really, it changes the denominator aspect of it. You know what I'm saying? If you got questions on that, let me know. But be conscious of that on the exam. Be ready, because I'm going to say no negative exponents. And if you start with a radical, end with a radical. Okay? Okay. Any other questions that have come up? All right. Several of you on number 3, writing the equation of the line, you took the derivative of f of x. You got to be mindful of this now. This test is going to be all about derivatives. It's going to be packed full of derivatives. And you got to look at what you're taking the derivative of. If what's in the parentheses is not just x, okay? If it's something else, if it's minus x, which it is in number 3, you got 1 minus x in there. Therefore, you got to use the chain rule, okay? And the chain rule, you could use it if it was just x, but the derivative would be 1 when you do the inside the parenthesis derivative of what's inside the parentheses. But the idea here, several of you left off the minus sign because you have to use the chain rule. So you brought the 3 down nicely, subtracted 1, so you made the exponent 2. 1 minus x was in parentheses. But then when you had to multiply it, you have to multiply it by the derivative of what's inside the parentheses. And that turns out to give you minus 1. That makes it minus 3 out front, okay? So it makes the slope negative, and that becomes negative 3x plus 1, all right, in the process of doing the problem. So y equals negative 3x plus 1 was the correct answer, all right? And listen, also on the second test, going through the second test, I dropped the rewrite possibility on the quiz to 60%. So let me say this. Any question that you got less than 60% on, and that means any portion. So each question that's worth 2 points means if you got less than 1.2 on one question, you can redo that and I'll give you credit up to 1.2, okay? So all the other questions were worth 2 points each. So if you got something less than 1.2 on any of the specific questions, that includes 1, 1, and 1, 2, and 2, 1, and 2, 2. Those, all right? Make sure you can feel free to rewrite it, do it on a separate piece of paper, or if you do it on the same quiz and take a picture of it, make it a different color, put a square around it. You need to make sure it's clearly a different problem, okay? You rewrote it and show me that you get it. Don't just put the correct answer down. You won't get credit for that, okay? So, anybody have questions on that at all? Okay, tell you what. One thing I want to do, if questions come up, make sure you, I've got chat on, and I've also got, make sure you let me know if you've got questions, or just speak up, unmute yourself, because right now, I see you, it looks like you're all muted. But what I want to do right now is, I'm going to get rid of these scores here, but you guys, that was really strong to have 16 of you above 90%. That's fantastic. And those of you that weren't, get it down, check out what you did wrong. If you've got questions, get with me or get with Math Lab. Remember those instructions between 5 and 7 in the evening. Make sure you get in touch with them. There's a couple people that have turned in, that have gone there. That's already, they let me know about that. And that was pretty cool. All right, so what I want to do now, I'm going to get that grade off the screen. And let's move to I'm going to erase that and move on to ICP3. So what I want to do right now is I want to go back and turn on the in-class problem here. Let me back off here. Turn on ICP3. Okay, so it's open now in under week 3. In-class problem set number 3, it says. Okay? And I've got it set up. I would like you to do it and turn it in. You have until like 10 o'clock tonight, all right, to turn it in. And that's what but you can turn it in right after class. I mean, before we end class, we're going to do it right now. So you have the choice of doing it. I've got it set up until 10 o'clock tonight. All right. So what I want to do right now is go through the problems. So open up in-class problem set 3, if you would, and let's work through those. 2 of them, I've got a couple of what do they call? Implicit differentiation problems. And one of them I ask you to write the equation of the tangent line. But then I also ask you to do a gravity problem on the next page. And let's go through those right now if you could, all right? So what I've done is I've put, does everybody have it open? Is anybody not able to look at the problem set right now? Okay, now work neatly. You guys, I'm going to ask you to upload this today. And several of you last time, you got it uploaded before class was over. That was totally fantastic. And that's kind of what I'm hoping you'll do. So take advantage of it. Get it done. As soon as you get it done, get it back to me, all right? And that's the idea. But let's work through this. So the first, I'm going to open up to see the in-class problem right now myself. I've got it written down here. But the first question is, all right, so it's saying let me share this on screen. I'll share it. I'm gonna go to my iPad. What I'm gonna do. So look at the problem with me, and in a minute I'm gonna go to the iPad. I said determine the equation of the tangent line to the graph of x squared minus 3y squared equals 1 at 2, 1 and at negative 7, 4. Well, all I want you to do is write the equation. We can plug in negative 7, 4 in a second, but let's just write the equation for 2, 1. That you can see part B. That's all I'm saying is write the equation of the tangent line. So for right now, let's first find dy dx, all right? And one of the things I did mention last time was there's a shortcut that you could use. And the shortcut is, not a shortcut as much as just an abbreviation. Y prime, sometimes people use y prime instead of dy dx. Remember what you're finding. If you make y prime equal to dy dx, just note that and use y prime. Sometimes it can be a lot less writing and it can be a little less cumbersome or whatever that type of situation. I'll start with dy dx and move to y prime for the second one or something like that. All right, so let's do this. I'm going to go to the iPad now. And everybody okay?
Peanut.
Okay.
Come here. Come here.
All right. I tell you what, I think I might, I noticed somebody's got a little bit of noise on, so your mic's open. I think I might mute you. So I want to remind you, if you've got a question or something, make sure you get my attention and open your mic and speak up, all right? I've got it set up so you'll be able to unmute your mic. But right now, I need to set it up so that we're all muted together here. You're all muted. Okay, so you are muted. And you can unmute yourself, but I've got you all muted now, okay? So you can unmute yourself. If you want to, make sure you unmute yourself and get my attention. But intentionally, I heard a little background noise, and therefore I'm moving on to this. Okay, so the first question was to come up with the equation of a tangent line to this graph, okay? And if you want to look at that on your Desmos or something like that, you can. It's a hyperbola, and it is a situation where you've got two V's with a rounded base curve going away from each other type thing. And the question is, first, determine the slope dy dx of the tangent line using implicit differentiation. Dig in, do it right now yourself. I mean it, do it, try it. I'm gonna do it right now. So the whole thing is, the whole thing comes down to, so what we need to do is, I'm going to use the symbol dy dx every time now, okay? So I'm going to use d dx each time. And I'm going to take d dx of each term. So I'm going to d d dx, take the derivative with respect to x of x squared minus the derivative with respect to x of 3y squared equals the derivative with respect to x of 1. All right? And if at any point I make a silly or something like that, or if I write something wrong, you guys speak up, okay? Make sure you let me know so that we'll all be on the same page. The derivative with respect to x, if you've only got x in the term, yeah, then you're just taking the derivative of that term. Also, let me backstep. Remember, look at the original problem. How many y's are in this function? 1. That means there's going to be 1 dy dx. So the idea is you're going to just get everything else on the other side. Once you get all this, take the d dx of each term, then there's just going to be 1 dy dx, okay? Make sure you know that, and we'll talk about the second problem. There's 2 of them there, okay? So in this situation right now, the derivative with respect to x of x squared is 2x. The derivative with respect to x, I've got a minus. Make sure you know that. I've got a minus, and I've got 2, bring the 2 down. The derivative of the outside, remember, we got to use the chain rule anytime there's a y. So I can do the derivative of the outside, which is 2 times 3y, which is 6y, to the first, I'm not going to put the 1, times chain rule, the derivative of y with respect to x. This is one advantage of using dy dx, because you know, that's a literal. When you use y prime, sometimes you can lose track of that's what you're doing. And then the derivative with respect to x of a constant is 0. Questions on that step at all? Okay, let's get rid of the parentheses, and then we're going to solve for dy dx. Okay, so what I'm going to do is I'm going to try to make it as positive as I can. So instead of subtracting the 2x, I'm going to add the 6y dy dx over to the other side. So I end up with 2x, positive 2x. If I subtracted it, they'd both be negative, and then I just have to remember to divide by a negative. Whatever, I'm just going to add, and that's going to end up being 6y dy dx. Okay? Now to get dy dx, this is multiplication. I got to divide by 6y. So I'm going to divide by 6y. That gives me 2x over 6y equals dy dx. Okay, and therefore dy dx equals, I'm going to reduce that, that's equal to x over 3y. So on any point of the graph, the original graph, the situation is going to be that it is, this is the equation for the slope. You plug the x coordinate and the y coordinate in, and you get the slope of the line, of the tangent line, okay? And I've asked you in this first problem to do it for, what was it, 1, 2, I think? Yeah, at 2, 1. At 2, 1. So that means at y is 2, this is, x is 2 and y is 1. So I end up with, this ends up being then x is 2 and y is 1. I end up with 2/3. So m is equal to 2/3. So the answer to the first question now, let's go back to that. The first question was, what's dy dx? There's the answer. X over 3y. dy over dx equals x over 3y. That's the answer to part A, 1A. Okay? Now, what's the equation of the tangent line through 2, 1? We have to figure out the slope. I've got m equals 2/3. And now we've got to use, I've got the point is 2, 1. Therefore, I'm going to do y equals mx plus b. Y is 1, m is 2/3, x is 2, and plus b. I've got b equals, I'm going to make it 1. I'm seeing a denominator of 3, so that's going to be equal to 3/3 minus 4/3. Okay, pardon me, let me rewrite that step. So that's equal, 1 equals 4/3 plus b is the next step. And then the follow-up is to subtract. I change the 1 to 3/3 and subtract 4/3. So I end up with negative 1/3. So it turns out being y equals m x plus b. There's the equation of the tangent line. Okay. Notice that 2, 1 is on the graph. You plug in 2, you get 4. minus 3 equals 1. Notice also, I put it as a second point. You could also check what's negative. What about negative 7, 4? Would that work? We get negative 7, 4. At negative 7, 4, I get negative 7 squared minus 3 times 4 squared equals 1. That's 49 minus 3 times 16 equals 1. 49 minus 48 equals 1. Yahtzee. It's part of the graph. And then if I plug in negative 7, 4 into this, I'll have the slope at negative 7, 4 also, okay, if you're doing that. Rather than doing that, I want to go on to that second problem, number 2 down there, okay? Any questions about number 1, A or B? So the answer to 1B is this. The answer to 1A is this. Asking you what is dy dx? And that answer is x over y, 3 prime, over 3y. Okay? Let's go down to number 2. I'm going to call up a new notebook here. And I end up with now, let's hit this. So I've got now, the equation is x squared minus xy plus 4y equals 2. You know, on that first equation, the minus sign separating two perfect squares of x and y, notice if you look on Desmos on the graph of that, that is a function. Oh, no, it's not. It's not a function because it's the sideways u, you know? So it doesn't pass the vertical line test again. Hyperbola doesn't. So, pardon me, that's a unique one. But you feel free to look at the graph on that and verify the circumstances around that and be clear with it. And write the equation of your line that we got. Hit the graph with it and verify that it touches at one point. Okay, now number 2. So this I'm not asking you to write an equation. I'm just saying determine dy dx just for practice, okay? So you want dy dx. So right now what I'm going to do instead, I've got to remember, I'm going to use y prime this time, okay? I'm denoting that I'm going to use y prime instead whenever I need to use the dy dx. So I can remember I've got to answer the question with dy dx. So right now I'm gonna take the derivative of each term, and so for right now I'm going to use d dx again to start with, and then I'm going to convert to y prime across the board. Okay. So what I'm going to do is I'm going to take the derivative with respect to x of x squared minus the derivative with respect to x of xy. Well, that was kind of messy. Don't do that. All right, of xy plus the derivative with respect. Oh, the reason I did this is because I wanted you to see a function where there's more than one y. Derivative with respect to x of 2. More than one y. So looking at the original function, there's 2 terms with the y in it. Therefore, dy dx is going to show up twice. There's going to be 2 of them. So that means I'm going to have to get them all on the same side, factor it out, and divide by what's left over. Okay? That's going to be part of what's coming. So when you see a problem, be thinking about that as it's developing, you know? Look at this right now. I've got 2 dy dx's. I'm going to have 2 dy dx's. Or at first, I'm going to change it to y prime. So what do we have here? What's the derivative of x squared? We've got 2x. Now the derivative of product. Got to use the product rule. So if we've got y equals fg, then y prime equals f prime g plus fg prime. Again, if you have those switched, you can. That addition's commutative, but I'm doing it this way to match the quotient rule. You know, the f prime g first. Okay, so now I've got minus in parentheses because I've got 2 terms coming. I need to have it in parentheses. This minus sign has to hit both terms. Okay, so I've got f prime times g. F prime, the derivative of x is 1 times g, y, plus f, x, times g prime, the derivative of y. Here we go. So now I get the derivative of y is dy dx, or y prime. You know, it's 1 y prime. Okay? That's what the situation is there. I'm using y prime instead of dy dx. And if you use dy dx, it won't be wrong. I'm just saying I want to do that. Now I'm using plus the derivative of the next term. Okay? got to use the chain rule. Every time there's a y, we got to use the chain rule. So it turns out we've got plus the derivative of 4y is 4, you know, if that was 4x, it would be, the derivative would be 4. But this is 4 times we got to use the chain rule, and that's going to give us a y prime, dy dx. Okay, that's y prime. And that is now, we've got the derivative of 2 is 0. Okay, with respect to x. Everybody okay with that so far? Okay, now the goal is to get all the y primes on one side and factor it out. There's 2 of them, so factor it out and make sure it's clear. So first thing I'm going to do is get rid of the parentheses. So it's going to be 2, distribute that minus sign. That's minus y minus x y prime plus 4y prime equals 0. Now I'm going to keep the y primes on the same side. Then I'm going to take the other 2 terms over to the other side. That means they're going to switch signs over there. So over there, I'm going to add y. So I've got to add y, and I'm going to subtract 2x. And on this side, I'll tell you what, I'm going to put the 4 first and subtract. So it'll just be a subtraction instead of multiplying, or, you know, starting with a negative sign. Okay, does everybody see where this comes from? Notice on the other side, negative y becomes positive y, 2x becomes negative 2x. These 2 I kept over here, but I just switched the order so I'd have a subtraction problem instead of a negative plus a positive. All right, now I'm going to factor out the y prime. All right, and now I'm going to get the y prime by itself. I'm going to divide by 4 minus x. So I end up with y prime when I divide through by that 4 minus x equals y minus 2x over 4 minus x. All right, and what's a trip is that that is the slope, and it works. That is the slope at any point on this graph. Okay, so that's what I just wanted you to practice, doing one that had 2 terms that had a y in it also. Okay, any questions about that at all? Okay, there's going to be one of those on the exam tomorrow. So make sure you're conscious of that. And if I ask you to write the equation of a line, be able to do that, get the slope point or point slope. I'll give you the